Hi again. I wanted to do one more example. This is similar to another couple of examples that you have in your homework. We did already one with the big fraction. Check this one out for kind of some multiplication. If you've already watched the previous video, we kind of talked about a process, but in brief, what it means is we deal with the outside negative exponents first, then the inside negative exponents, and then we'll kind of simplify and work on things as we go along. It's not going to be exactly the same process for this one because we have two separate monomials that we're multiplying together as opposed to a fraction that we had a bunch of stuff going on in. But we'll work our way through it. In this particular case, I would in fact suggest that as the first step, we take care of this negative and the 5 at the same time. We're going to use the third rule of exponents that you probably remember, just to review them quickly here. A to the 3, or a to the 5, times a to the 2 is equal to a to the 7. 5 times 2. A to the 5 divided by a to the 2 equals a to the 3. 5 minus 2. And a to the 5 to the power of 2 is equal to a to the 10. 5 times 2. And it's that last thing that's going to be proved to be useful here. Negative 5, I'm going to raise everything to that power. I'm going to distribute, I shouldn't use that word. We're not distributing the negative power. What I'm doing is I'm multiplying each of the terms, each of the pieces of that monomial to that power. So I have x to the 3 to the negative 5, and then y to the negative 4 to the negative 5, and then z to the 3 to the negative 5. The reason why I want to do this first is because my negative exponents, some of my negative exponents are going to cancel. So I'm going to combine everything into one monomial, so I have all of my x's together, all of my y's together, all of my z's together, and then I'll deal with the negative exponents after the fact. When you already have a fraction, it's a good idea to simplify inside the fraction before you combine, but when you're multiplying different monomials like this, I suggest combine the monomials and then deal with the pieces inside the parentheses. So x to the 3 to the negative 5, using this rule, that gives me x to the negative 15. Y to the negative 4 to the negative 5 gives me y to the positive 20. Negative times a negative is positive. Z to the 3 to the negative 5 is z to the negative 15. Now that's still times x squared y to the negative 5 z. But now I can use this property, because I have x to the negative 15 times x to the 2. That gives me x to the negative 15 plus 2. So x to the negative 13. Y to the 20 times y to the negative 5. 20 plus negative 5 is 15. Then z to the negative 15 times z. What power is there if there's no actual power written? It's 1. So this would be z to the negative 14. And so finally, my last step would be to have y to the 15 on top, because that's a positive exponent that's going to not move. X to the negative 13 is going to turn into 1 over x to the 13. Z to the negative 14 is going to turn into 1 over z to the 14. And so I'll combine them all into one expression, like so. And so that would be my final answer in that particular case. Use the rules of exponents to get all of the x's, y's, and z's together. And then after you get to that, then you should deal with the negative exponents. When you have negative exponents in a fraction, like in examples 10 and 13, for example, use the process from the previous video. But for a lot of the other examples, you're going to want to do something kind of like this.